In this video, we're going to discuss how we assess reliability, and then we're going to do an example in our statistical software known as JASP. Um, Internal consistency. Let's get to the definition of internal consistency. I know you read this in your textbook, but I wanted to explain this a little bit more. So I have this example scenario here. It says, suppose we gave a survey to a random sample of individuals, and there were five items 1 through 5, that measure some underlying construct, right? And so, an underlying construct in the social sciences is any phenomenon that we can't physically measure, and we usually use survey items or something of that nature to get an indication of the level that individual may be on that construct. And so an example of that would be like us measuring intrinsic motivation. And so if we're going to use these five items to measure intrinsic motivation, then we need to provide evidence that the items are actually or might actually be measuring intrinsic motivation. And one way to do that is to look at those items and the way that people are responding to that item, and saying, okay, well, most of the people are giving very similar responses to that item. And so that might be evidence that this is measuring the same, these items are measuring the same underlying thing. And we're going to call that underlying thing intrinsic motivation. All right. And so basically what we're going to do is we're going to calculate the inter-item correlations, or the correlation between the item responses. And if that is high, that means we have good internal consistency, which means we are reliably measuring that construct. So if we wanted a definition, internal consistency refers to the extent to which items on the scale or a subscale work together to measure an underlying construct. And one way we can do that is by looking at the correlation of the item responses. Well, we can compute internal consistency, and I'm going to start using the term reliability kind of interchangeably with internal consistency, because it is a type of reliability. There are multiple other types, but we're going to focus here on internal consistency. One of the most commonly used methods for computing or estimating internal consistency is Cronbach's alpha. All right, and that's the Greek symbol there you see on the screen for alpha. It basically computes the correlation between your responses to all items in the scale or a subscale, that those items that are supposed to be measuring that underlying single construct. The value of alpha should range between 0 and 1, where the closer it is to 1, the more evidence that we have that our items are internally consistent. Just as a rule of thumb, we would like for alpha to be at least 0.7 in order for us to say that we have adequate internal consistency or adequate reliability to use those items to measure that construct. Now, the advantage of using Cronbach's alpha, it is not the only method used for internal consistency. But it is the most commonly used method for computing internal consistency, because it is based off of correlations, and correlations are considered to be simple. And Cronbach's alpha is probably incorporated in most statistical software programs. And so you'll see a lot in the literature that when people report internal consistency estimates, they report Cronbach's alpha. The disadvantage of using Cronbach's alpha, and this is becoming more and more known now, and so I think we're getting a paradigm shift. But Cronbach's alpha provides a lower bound estimate of internal consistency. So it gives us an estimate, but it's the lower bound, the smallest value that we expect the actual internal consistency reliability estimate to be. All right. And statisticians usually say that a lower bound, or a value from estimates that gives you a lower bound, is something that we call conservative. It's conservative. And so there are alternatives to Cronbach's alpha. One is to calculate a confidence interval. Now, a confidence interval is a statistical inference method that we're going to talk about later in the semester. But since we're on Chromebox Alpha, and this is one of the methods that you can use to potentially get a better estimate of Chromebox Alpha, I'm going to go ahead and describe it here. If we conduct or construct a confidence interval for Chromebox Alpha, we're going to get a range of values, meaning I'm going to get two numbers, a smaller number and a larger number. And what that confidence interval is saying is that I'm pretty confident that my true value of internal consistency will lie between those two values. All right. Another method is to use McDonald's omega. And there's the Greek symbol for omega. It looks like a W almost. But this is another estimate of internal consistency. And we're starting to see this a lot more in survey research being reported. It is a more accurate estimate of internal consistency, and it's calculated not just using correlations. It's calculated using factor analysis. Factor analysis is a multivariate statistical method and framework that is beyond the scope of this course, but it has some different methods of calculating how internally consistent those items are, which makes it a little more accurate. Although it is calculated differently, we will still interpret it in the same way that we interpret Chromebox Alpha. So we want McDonald's omega to also be greater than or equal to 0.7. If it is greater than or equal to 0.7, we can use that scale. We have evidence that our items are working together to measure a single construct. If we don't get a value greater than or equal to 0.7, we don't have enough evidence, and we may want to revise our items, maybe drop some of the items that may not be working well with the others, but do some kind of revisions before we actually try to use those results from those survey items in some statistical analyses. So what we're going to do is we're going to go to JASP in just a few moments, but I have an example here. And in this example, we have 6,901 6th to 12th grade students who have been surveyed. And these students have been surveyed at rural school districts in South Carolina. And so there's a lot of items. You'll see the actual data set in our Blackboard course. But there is a few items that make up a scale that measures the construct known as school value. All right, so I'm going to look at these items here that measure school value. So this is the construct, and there are 1, 2, 3, 4, 5 items, and I have abbreviations in their actual variable names in a data set. But these are the items that measure school value. Rarely pay is one item in the data set. It's given by RARE pay, rare pay. There's a item on the survey about dropouts, and so that's the variable name in the data set there. We have bad grades, school is a waste of time, and scholarships. These items together supposedly measure school value. And so what we're going to do is we're going to use JASP to obtain an estimate of internal consistency to see if we have evidence that these items are truly measuring school value. Well, the first thing you're going to want to do when you use JASP is to import your data. Now, it's a free software created by great statisticians. It goes through updates, and sometimes the updates go beyond what I may have in our notes here. It was recently the case that it could only import .csv files, comma delimited files. I think it can now import Excel files or .xlsx. But for us, let's just stick to .csv files so we can ensure that the program will import our data. So you want to save your data on your computer as a .csv file and make note of the location because you're going to have to go and find it. And then you're going to import that data into JASP. I'll show you how to do that by going to the file or the menu icon in JASP We're going to go to open computer, and then we're going to select the file on our computer. And you're going to see that data being imported. In order to get our internal consistency estimates in JASP, we're going to have to add a reliability menu if it is not already there. And then within that reliability menu, we're going to go to classical and then unidimensional reliability. Notice here I'm using that word unidimensional here. I didn't talk about it before. I remember saying single construct or measuring an underlying construct. When we use Chromebox Alpha or McDonald's Omega as an alternative, we're looking at the internal consistency of measuring a single construct. That means our items are unidimensional, one dimensional, right? And so that's why a JASP is using this type of language. So I'm going to go to JASP. It's already been downloaded on my computer. This is what JASP looks like when we open it. And so what I'm going to do to import my data, this is my menu here, these three horizontal lines. I'm going to go to open. I'm going to go to computer. And you can go to browse your computer. And so we'll browse our computer. I already have some stuff in a folder on my computer. I have this saved in a folder called reliability. You need to know where you've saved your actual stuff. Notice here I have two files that has my data. And if I extend this menu here, I'm going to extend this to so that you can see it. I have it saved as a CSV or a comma separated file here. And I also have it saved as an Excel file here. Either one of these are going to work, right? But the traditional method is to import a .csv file. And so I'm going to import a .csv file. I'm going to click open. As you can see here, it's importing my data. And now I have all of my variables in that data set. So each column here represents an item on that survey, right? All of these numbers, like the 6s and the 4s and the 5s, we have some 1s here. These are the item responses, all right? Now I can scroll up and down, but if I scroll all the way down, I can see that I have 6,901 responses. So my full data set has been uploaded. And I know I'm going to be looking at those items. There's that rare pay item there, dropout, BD, all that stuff right there, right? Now, I want to calculate internal consistency. These are the types of statistical analysis groups that we'll have here. In order to get an internal consistency estimate, I need to see the reliability menu. I don't see that here. So I'm going to go to this blue plus sign here, and this allows us to add more statistical analyses. All right. And now, if I scroll down, I'm going to see reliability here. I'm going to check that. And now I have this reliability menu here. So I'm going to open this reliability menu, and I'm going to go to unidimensional reliability. This is what we're going to use to actually calculate our reliability. Now, in order for this to work for us appropriately, especially with this data set, we got to tell JASP what to exactly do. So I went to this advanced options menu here, and I'm going to scroll down to the section that says missing values. It's now on the pairwise, that pairwise is selected. I want to select delete listwise. This is basically telling JASP what to do with missing values, right? So if I go to those items, those 5 items on that scale, if a student is missing any of those items, it's going to remove that student from the data set so that we only have students that have responded to all of the items. There are other methods to handle missing data. That's going to be beyond the scope of what we're going to do in this course. So right now we're just going to use listwise deletion. Now, that is all I need for this menu here. Now, in order for me to calculate the internal consistency, I've got to tell JASP which items, right? And so all of my item names are listed here. And I've got to find those 5 items that I was interested in. And it was actually the last 5 items in that data set. So there's that rare pay. We have the dropout, bad grades, school is a waste of time, and scholarships. If you do shift and you click that last one, you can highlight all of them, click this arrow, and it's going to add those variables to our data set. All right. Now, I'm not going to look at this yet because I'm going to take this step by step. Now that I have selected my items, I'm going to go through, I'm going to uncheck everything in here, and I'm going to tell JASP to calculate Chromebox alpha. Now, it's saying coefficient alpha here. It's the same thing as Chromebox alpha. When I click on that, I get the estimate of Chromebox alpha of 0.376. That is the estimate, all right? So I will compare that value to zero point 0.7. It is smaller than zero point 0.7. That means this scale here doesn't have good reliability or good internal consistency. Remember when I said that an alternative to this alpha, because this isn't a lower bound, I can calculate a confidence interval to see between which numbers I believe the true value of internal consistency reliability will be between. Notice here this section says 95% confidence interval. It has a lower bound and an upper bound, and it starts at 0.35 and it goes to 0.402. So I'm saying I'm 95% confident that the true value of Chromebox alpha is between 3.5 and 0.402. Now that gives you a little bit more, but it's still based off of an inaccurate lower bound estimate of internal reliability. And so the field now is moving towards McDonald's omega. And so for me to get an estimate of McDonald's omega, I can go here to coefficient omega. I'll click on that, and notice I'm getting a value of 0.439. And so this is a better estimate of that reliability. It is still below 0.7. And so I need to go through a revision process to see if I can get better reliability. I may have to remove some items. Maybe that can give me better reliability that's above 0.7, so on and so forth. So one of the tools that JASP has that'll allow us to evaluate whether adding removing an item would help is I can go here to coefficient alpha. I'm going to click that under individual item statistics. This is coefficient alpha if the item is dropped. All right. And so I have my 5 items here. And under this column that says estimate, it gives me the estimate of internal consistency for alpha if I dropped this item. So if I drop bad grades, my coefficient alpha would now be 0.206. If I dropped dropout, that item, my value of coefficient alpha would be 0.206, so on and so forth, right? And so one of the things that we can do is we can compare the alpha that we got here to the alpha that we would get if we drop these items. And if any of those are substantially larger or significantly larger, then we may say, okay, my scale would be better at measuring this single construct if I remove this item, right? And so notice here, for that scholarships variable, if we were to remove it, alpha would jump by approximately, well, not 0.2, but from 0.376 to 0.526. And so what we can do is we could remove this item. So I'm going to click on it in this box. And notice here, when I clicked on it here, I can use this arrow to remove it. And we'll see that alpha would be 0.526 and omega would be 0.54. And if I notice, I can go back and look to see what happens if I remove any other items. And I'll say that maybe this zero point 0.6 here isn't large and different enough from that 0.526. And so I can remove that item, like rare pay, and I'll get a zero point 0.6. And so maybe this scale is is better at measuring with these three items instead of those five, right? But that's a process that you can use to see if you can get a better reliability. In any case, because this reliability is going to be upwards of zero point 0.6 or zero point 0.61, these items, the five or the three that I have here on the screen right now, they're not going to be well enough or have a high enough internal estimate, internal consistent estimate for us to use this in kind of peer reviewed publications. All right. And so I will probably think about, oh, maybe I need to reword some items, or maybe I need to add some additional items to the scale to see if it measures something else. Or it could just be evidence that I'm measuring more than one thing and I don't have that unidimensionality um, that is, which is what we're checking when we're doing internal consistency. All right. And so that is that. Now, what I'm going to do here is I'm going to remove all these items and I'm going to redo an analysis based off of, let's see, this item here to this item here. I believe those items, I don't remember what those items are measuring, but I know that this is another subscale. And by the way, if you go to the data set that's given in Blackboard um, as an Excel file. I'm going to pull this up right quick. All of the items that are measuring the same construct are given here in the same color. So items from success to outrec or outreach, outdoor recreation potentially, those are all measuring the same one construct. These next items in this data set are measuring another construct, and then these items here are measuring a construct. That's what we're going to look at next. And these were those last five items. They were supposedly measuring this construct. And so I'm going to select those items and let's see what values of internal consistency we get, right? If we only want it at coefficient alpha, we see that we have a very high estimate of internal consistency, 0.877. Alpha, if our items are deleted, notice here if I delete the item, only one of them increases, and it's this one here, and it only increases the value of alpha by 0.002, which is not large at all. We're moving toward calculating coefficient omega, so I'm going to check that there, and we see that the coefficient omega value, our estimate is 0.880, right? And so right now, we're kind of on the shift of a paradigm, right? And so some people may say report alpha and omega and their confidence intervals to show that you have evidence that your data, your items that you're using in your study has internal consistency reliability. Those are the popular two methods. There is the split half coefficient that your textbook went over. That's not used as often as coefficient alpha, and then which we're currently trying to replace with coefficient omega. And so I'm going to skip over that. If you wanted to get an estimate of that, you can with this program here. All right. And so I'll say that our internal consistency estimate for these five items shows adequate internal consistency with a coefficient alpha value of 0.877 with a confidence interval of 0.87 to 0.88 and coefficient omega 0.88 with a a 95% confidence interval given here. This shows that this scale is measuring accurately um, the construct that it is measuring. All right. And so I'm going to stop here in this video. And if you want to, you can look at the other items from that other scale and get an estimate so that you can get some practice also calculating internal consistency.